Hello, good morning. How are you today? I hope all of you are well and excited to learn this time. So, today we will learn about linear function and how to identify a linear function. Before we start it, we must know what is a linear function. The graph represents a function because its domain value or x value is paired with exactly one range value or y value. Notice that the graph is a straight line. A function whose graph forms a straight line is called a linear function. That's it, the definition of a linear function. In addition to definition, we can identify linear function using graph and ordered pairs. For the first, we will learn about identifying a linear function using a graph. As we can see, there are three different graphs. Graph 1 is a linear function. Why? Because its domain value is paired with exactly one range value, and the graph forms a line. In the graph 2 is not a linear function because its domain value is paired with exactly one range value, but the graph is not a line. And then in graph 3 is not a function because the only domain value 3 is paired with many different range value. For the second, we will learn about identifying a linear function using ordered pairs. We can see that in example A and B there are ordered pairs. Then write down the ordered pairs in a table and look for the patterns. In table A, a constant chance of +3 in x corresponds to a constant chance of -1 in y. This point satisfies a linear function. In table B, a constant chance of +5 in x corresponds to a different chance in y. This point do not satisfy a linear function. Another way to determine whether a function is linear is to look at its equation. A function is linear if it's described by a linear equation. A linear equation is any equation that can be written in the standard form shown below. And this is a standard form of a linear equation. ax plus by equals c, where a, b, and c are real numbers, and a and b are not both zero. Notice that when a linear equation is written in standard form, point A, x and y both have exponent of 1. Point B, x and y are not multiplied together. And point C, x and y do not appear in denominators, exponent, or radical sign. And this is an example from standard form of a linear equation. In the table on the left side is a linear example. Example number 1, 3x plus 2y equals 10. This is a standard form of a linear equation. Example number 2, y minus 2 equals 3x. This can be written as 3x minus y equals minus 2 because we can subtract both sides by y. And example number 3, minus y equals 5x. This can be written as 5x plus y equals 0 because we can edit both sides by y. In the table on the right side is not a linear example. And example number 1, 3xy plus x equals 1. This is not a linear because x and y are multiplied. And example number 2, x cubed plus y equals minus 1. This is not a linear because x has an exponent. In example number 3, x plus 6 over y equals 12. This is not a linear because y is a denominator. Let's see the example. Tell whether each function is linear. If so, graph the function y equals x plus 3. And then we can subtract both sides with x. And then y minus x equals x minus x plus 3. And then y minus x equals 3 because x minus x is 0 and 0 plus 3 is 3. And then minus x plus y equals 3. The equation is in standard form where a equals minus 1, b equals 1, c equals 3. To graph, choose 3 values of x and use them to generate ordered pairs. As we can see in the table, we can substitute x value and then we get the ordered pairs. For x equals 0 is 0,3, for x equals 1, 1,4, for x equals 2, 2,5, and then plot the points and connect them with a straight line. Then the function is a linear function because its domain value is paired with exactly one range value and the graph form is a line. Maybe that's all from me. Hopefully the material that I convey can be useful for all of us. Thanks for your attention. See you!